Hello, everybody. Welcome back. Good morning and good evening. My name is Vinay, and I take great pleasure in welcoming you all. In today's session of Active Threat Analytics, we will deep dive on how to investigate the dashboard, which presents the potential security breach cases based on different mechanisms.
Hello everyone. Good morning, good afternoon, and good evening. I'm Nutan, and in today's webinar, we would cover one of those important features of Guardium, that is Guardium Active Threat Analytics. So we'll have a short overview of Active Threat Analytics just to understand what it is and what is the purpose and how we can achieve that. In this demo, we'll go over cases generated by Active Threat Analytics and see how you can see the data and how you can look deeper into those. So let's understand Guardium. We know Guardium is collecting data from database activities, exceptions, and so on. We have the policy, which is like a filter, and everything that goes within this policy is logged within Guardium. Now, this data can be used with alerts, reports. We also have some dashboards. Everything you need for compliance is there. It is great. But then, if you want to go to another level, and if you want to also have some security, where security is more than just reports and alerts, then this is not enough. The reason is that there is so much data that there is no way to look at it and analyze it just from the reports. You need to have some another level, and that is where analytics is placed. So now let's see where Guardium Analytics fit. So Guardium Analytics consists of three main features: investigation dashboard, active threat analytics, and risk spotter. Investigation dashboard is used to analyze data and investigate cases. It is a visual tool where you can define charts, filter out the data for a particular time frame for specific DB users, collectors, and so on. We'll go over this during a demo. Active threat analytics, today we'll cover this topic in depth. Risk spotter, this analyzes the database users and determines their risk level. It also samples unmonitored users and evaluates their risk. In upcoming webinar, we'll focus on risk spotter as a new session. Let's see how a typical active threat analytic page looks like. So this is an active threat analytic main page, which has two sections. At the top section, we have some statistics that shows the number of open cases in the defined time range. So here, if you see the defined time range, what I have selected is last 3 days. And these are the cases which are open in this time range. So these cases are as per high, medium, or low severity. Then we have how many databases we have with high, medium, low severity, how many database users we have with high, medium, low severity. This graph over here, users per max risk range chart, this shows the number of risky users sorted by their risk score. This data is provided by the risk spotter and it is available only if risk spotter is enabled on your environment. This bottom section, it is a table that lists all the threat cases, open cases in this defined time range. By default, this table is ordered by the case severity. You can use this table to investigate a case, assign it to further investigation, or simply close it. Or you may want to perform few more actions. Now, this will go over during our demo, what all actions you can perform. Now let's understand our active threat analytics mechanisms. Active threat analytics is based on three mechanisms. We are not just using one, but three mechanisms to detect the threat cases so that we can look at the data with different perspective, slice it, and find the threat cases so that we can, further categorize those cases. The three mechanisms are outliers, threat finder, which is based on policy violations, threat diagnostics, also known as Eagle Eye. This presentation focuses on ATA, outliers, and threat finder. Now let's see what are outliers. Outliers are anomalies. Anomalies can be something normal because not every database activity is same all the time. Anomalies are typical for any database and database user activity. The reason we are looking out for outliers is that the threat, the attacks, these are often categorized by anomalies. They cause anomalies in the system. When we see an anomaly as a very high activity on the table, we can suspect someone is doing something wrong here. It can be the user, it can be someone from inside the organization, or someone from outside, a hacker. So, what we see here in the middle, we have an average, and then we have a standard deviation. And somewhere here at the end are the very rare cases. And those are the cases that really don't happen very often. These will be our outliers. We are really looking out for those most rare situations. Every outlier has an anomaly score, and the score is based on how far is this case from average. So higher the score, the case is more rare. Outlier mining searches for anomalies that are rare enough to be categorized as anomalies. The score must exceed a threshold to be called as an outlier. So, how do you define this threshold? To find anomalies, you need to establish a baseline to compare to. You need to first find out the normal behavior. The outlier mining process, it needs about 7 days of learning to establish the baseline. After 7 days, the process begins to compare each hour of activity to the baseline and it evaluates the anomalies. The threshold is configurable, however, it is not recommended to reduce it as it might result in false positive results. The number of training days is also configurable, however, we do not recommend to change that as we should have at least 7 days of initial learning. So now let's see the outlier statistical model. Outliers is based on statistical model, and this model is looking at two sources. What are those? Database and database user. It means that for every database and for every database user, we keep a statistical model that is giving us the normal behavior or the normal activities for that database and database user. Initially, when outlier mining process is started, this statistical model is empty. We accumulate the data when we get the activities from the sources. Now, what a typical end user would expect are favorite 5 questions, and that is what we are also targeting. We are looking at different aspects. Who? Who is performing the activity? Whether it's a database user or OS user. When was it done? We have different models for working and non-working hours, weekends, because the activity will be different for every database user in different time period. What are they doing? Which object they are accessing? What verb like select, update, grant, delete, or like drop, whatever. We also have a combination like object plus verb. Example here, like, can be select from a customer table, insert into an employee table. So a combination of object and verb. Then how? We are looking at the source program or the application from where the database was accessed. A user will normally have 1, 2, or maybe 5 different source programs they are using. If we see from one of the source program a very high activity, it will be an outlier on specific source program. We are also looking out for where, like client host name, to see the volume of activities from each client, from which client host name it is coming. So these typical 5 questions which any end user would like to know, and here we go. Now let's see what are the different outlier reasons. There are many reasons for types, what we call as types for outliers. Outliers might include more than one of these following reasons. What is a high volume outlier? It is a high volume of activities of some type. This can be like a high or a excessive select statements, high volume of grant commands. Now, what are the details you would like to know for this? We would like to know what type of activity was done. Was it a select, insert, or just an access to the table was given? New outlier. Every database user performs some kind of new activity on the database. It is not that they will always perform only fixed set of activities, but there is an average of new activity that every user does. Maybe one new activity in an hour or so, or maybe even less than that. A new outlier will be very high number of new activities done by this user for the first time. The details we would like to see is what new activity was performed in that 1 hour. Some examples, like I would say a select command is issued on a table which was never done before. A insert is done on a table which was again never done before. Maybe activities from some new application, maybe activities from some new client hostname. All these will be categorized as a new outlier. Vulnerable object. There is an object group called as vulnerable object group. We are looking out for the volume of activities on that specific group. Errors. Now, the number of SQL exceptions, if they are significantly higher than normal, it is like how many errors you have in an hour, then that kind of outlier is categorized, is typed as an error outlier. Diverse. Every user has a set of activities that they normally do. But every hour, they don't do all the activities that they did before. If suddenly we see a user doing a lot of different activities than usual, then it raises a suspicion that the account or credentials were stolen. And then that is as a diverse outlier. Ongoing outlier. Say that there was some anomaly with a high score, but that is happening for several hours. It can happen when there is an ongoing attack. If we see some high activity that continues for few hours, when I say few hours, not necessarily be consecutive hours, we will have this special type of outlier created that will tell us if someone is doing something from quite a while and it needs investigation. So, an outlier can have more than one reason. It can be diverse and also a high volume outlier, high activity. It can be a new and also diverse, and so on. Now, let's see active threat analytics by outliers mechanism. What are the different threat cases which are generated? Data leak. It means someone is extracting a lot of data. That is definitely a data leak case. Denial of service. Say a very high volume of activities is happening on a whole database. Normally, a activity like select happens just maybe a 10, 20 in an hour. But suddenly, if you see a spike that in an hour, it becomes 1,000 selects. This is something suspicious. A denial of service case would be generated. Account takeover. Normally, any database is accessed with one particular, say, a source application. Suddenly, if they see a new connection happening to the database, then that is an account takeover threat case. Schema tampering. Someone is trying to change the schema, and we see a lot of activities on this schema happening. A schema tampering case. Data tampering. As the name suggests, someone is trying to, update or delete, do those kind of activities, your data, a lot than usual. That is a data tampering case. Massive grants. A lot of grants has been given to, say, some particular user, which is not a normal activity. And suddenly, if you see that, that is a massive grant case. Anything else which is not part of these 6 cases, we call them as an anomaly. To know more about the outliers, you will see the link on the chat window. Follow the link to know more about outliers. Now, Threat Finder is another mechanism of active threat analytics. This is based on policy violations. It is the only mechanism used by advanced threat analytics that requires quick search to be enabled. Threat Finder runs on the central manager and it uses quick search to capture the violations from all the managed units. The out-of-the-box policy template, Basic Data Security Policy, it includes 5 policy rules that capture activities with syntax used in a known attack. This is a predefined policy, which I'll show you during our demo. Now let's understand how does this threat finder work. The policy rules examines all the individual SQL statements, and then it looks for some specific patterns. So when an activity includes a pattern that matches a rule, a policy violation is created. The threat finder searches for the policy violations related to the rules with a threshold. And if the number of such violations within 1 hour reaches the set threshold, an advanced threat analytic case is created. To know more about Threat Finder, you can follow this documentation link, which will be pasted in the chat window. Now, we have this policy, we have the rules, and Threat Finder has done its job. What are the typical cases it will generate? Cross-site scripting, OS command injection, SQL injection denial of service, SQL injection side channel, and SQL injection tautology. These are the predefined 5 cases as per the policy rules set in the basic data security policy. Okay, now we understand outlier mining, we understand threat finder. How are you going to enable that on your system? It's just one click and you're all good to go. Threat diagnostic, which we have not covered in this seminar, is enabled on the collector out of the box. Outliers and threat finder must be enabled. On the active threat analytics setup page, you can enable threat finder and outliers by clicking enable all process. Threat finder is enabled on the central manager and outlier mining is enabled on collectors and aggregators.